All right. Today we're going to talk about converting. We're starting trigonometry. Yay, in the unit circle. Okay, so first of all, we're going to talk about degrees and radians and measures of the angles of a circle. All right, DMS, which stands for degrees, minutes, and seconds, conversion facts. 1 degree is worth 60 minutes. And I don't really know. I don't really understand what minutes and degrees have to do. I know it's nautical, like 60 minutes north, or I don't know, 60 seconds south. It has to do with nautical measurements. Anyway, to convert between degrees and minutes, 1 degree is worth 60 minutes. 1 minute is worth 60 seconds. Okay, that's pretty much all you need to know, which you do already know that. So what you do is it says convert 37.425 degrees to DMS. Well, I already know how many whole degrees I have. So they want us to figure out how many degrees, how many minutes, and how many seconds there are in this many degrees. Well, I know the whole amount of degrees. So to figure out the minutes, you take the leftover degrees, the 0.425 degrees, and you convert. If I want to convert and I don't want degrees, I put degrees on the bottom and minutes on top. And my conversion rate is 1 degree is worth 60 minutes. Here, the degrees would cancel, and I'm left with 0.425 times 60. You type that in and you get 25.5 minutes. The whole number of minutes is 25. So that goes in that hole. What's left over is the 0.5 minutes that I need to convert to seconds. So if I want to get rid of minutes, I put minutes on the bottom and seconds on the top. And in 1 minute, there are 60 seconds. Minutes cancel, and I have 0.5 times 60, which is 30. So this would be 30 seconds. Done. 37.425 degrees is the same as 37 degrees, 25 minutes, 30 seconds. Alright, convert, now we're going backwards. They're giving me 42 degrees, 24 minutes, and 36 seconds, and they want me to go back to degrees. Well, what you got to start with is you have 36 seconds. Okay? I don't want seconds. I'm going to turn those into minutes. So if I want to get rid of seconds, I put those on the bottom and minutes on top. And let's see, in 1 minute there are 60 seconds. Seconds are gone. So if I take 36 and I divide it by 60, I get 0.6. So I have 0.6 minutes that I'm going to add on to this. So now I have 24.6 minutes that I want to convert to degrees. If I want to get rid of minutes, I put those on the bottom and degrees on top. And in 1 degree, there are 60 minutes. So minutes cancel. And I take 24.6 divided by 60. And I get 0.41 degrees that I'm going to add to the 42, which gives me a final total of 42.41 degrees. Okay? Alright, so you try this one, come back when you're ready. And hopefully you got 1. Alright, I'm going to take, we already know they want degrees, minutes, seconds. I already know how many whole degrees I have, 230. Okay, so I'm going to take my 0.14 degrees and I'm going to convert to minutes. I want degrees to go away. I want minutes on top. There's 60 minutes in 1 degree. Degrees cancel. 0.14 times 60 is 8.4 minutes. So I have 8 whole minutes. I'm going to take the 0.4 minutes that are left and convert it to seconds. I want minutes to go away. I want seconds. There are 60 seconds in 1 minute. Minutes cancel. And I do 0.4 times 60 and I get 24. So that would be 24 seconds. Yeah. Alright, so this one, go backwards, hit pause, come back when you're ready. And hopefully you got 3. Alright, so I'm going to start with my seconds, 49 seconds, and I'm going to convert back to minutes, seconds to minutes. There are 60 seconds in 1 minute. Seconds cancel. 49 divided by 60 is 0.816 repeating. Alright, so if I take that, that's how many minutes I have now, but I don't want minutes. So to turn minutes into degrees, I get rid of minutes, go to degrees. There are 60 minutes in 1 degree. Minutes cancel. Take the repeater, divide it by 60, and you get wait, what am I doing? Oh, silly. Sorry, I have to add this back to the minutes that I have, which was 47. Sorry, so I take 47.816 repeating, divided by 60, and I get the 0.79694444. Nearest hundred, 10th hundredths. 6 is going to bump that up to 10. Carry the 1 is 0.80. So if I add that on to my normal degrees, I have 343.80 degrees. Alright, so how do you convert between degrees and DMS? Write the conversions. 1 degree equals 60 minutes. 60 minutes equals 60 seconds. 1 minute equals 60 seconds. Okay, you use your conversions. Alright, arc length. When you're looking at a circle and you cut a sector of it, they call those a sector. It's like a piece of pie. What they're talking about arc length is like where the crust would be. Okay, that's what you're finding. You're finding the arc length. And the conversion rate is this. I think we're fine. No, I'm sorry. We're converting radians to degrees and degrees to radians. My bad. Okay, so what if you had a 30-degree angle, but you wanted to know how many radians that was? And a radian is just I don't know how to explain it. A central angle of a circle has measure 1 radian if it intercepts an arc with the same length as the radius. In other words, if this length, okay, is the same as this length, then your angle is worth 1 radian. Okay, it's just another way to measure. Instead of in degrees, you can measure in radians. At any rate, to convert from radians to degrees, you multiply by this. This is your conversion rate. So if I had 30 degrees and I want to go to radians, I would multiply. I don't want degrees, so I'm down here. Sorry. Let's do this one first. I don't want degrees, so degrees would go on the bottom and radians would be on top. And you have to know that in 180 degrees, that is worth pi radians. 180 degrees is worth pi radians. So degrees would cancel, and I'd end up with 30 pi over 180, and that would be 1 over 6, pi over 6. So this is what it would be. It would be pi over 6 radians. Okay, if you have radians, let's say that I have pi over 3 radians, and I want to convert to degrees, then you use this one. And again, think about it. If you don't want radians, you put those on the bottom. If I want degrees, I put those on top. And your conversion rate is there's pi radians in 180 degrees. Those cancel, and I basically have pi over 3 times 180 over pi. The pi's would cancel. 180 divided by 3 is 60 degrees. Okay? Alright, so it says convert from degrees to radians. The problem here is I can't convert degrees in minutes or degrees in minutes in seconds. You just have to have straight degrees. So your first thing you're going to have to do is, like we just learned, and convert these to degrees. Yeah, over here. Over here, we're good. Even though there's a decimal, it's all degrees. So if I want degrees to go away, I put degrees on bottom, and I want radians, that's on top. There are pi radians in 180 degrees. Degrees cancel. So I would have 71.72 pi over 180 radians. Now, to simplify that, 71.72 times pi divided by 180, I get approximately 1.25 radians. Okay, the second one I'm going to have to do a little bit of work. I have 24 minutes that I want to convert to degrees. So I want rid of minutes, I want degrees. There are 60 minutes in 1 degree. Minutes cancel, and I do 24 divided by 60 is 0.4. So this becomes 61.4 degrees. So if I have 61.4 degrees and I want degrees to go away, I put it on bottom, radians on top. There are pi radians in 180 degrees. So what I end up with is 61.4 pi over 180 radians. And if I simplify that, 61 times 4 pi, enter, divided by 180, and you get approximately 4.26 radians. Yeah. Alright, how many radians are in 90 degrees? In 90 degrees, if I want degrees to go away, I put it on the bottom. I want radians on top. There are 180 degrees in pi radians. The degrees cancel. And this gives me 90 pi over 180 radians. Now I can simplify this. The zeros cancel. 9 goes into 9 once, 9 goes into 18 twice. So I get pi over 9. And you could go decimal if you want, but a lot of times they'll just leave them in terms of pi. Alright, you try this one. Hit pause, come back when you're ready. Alright, 324 degrees. I don't want degrees, so I put degrees on bottom. I want radians on top. My conversion rate is there's pi radians in 180 degrees. The degrees cancel. And I have 324 pi all over 180. Now notice your answers are in terms of pi, so I don't want to use a calculator. You can, or 3.14. Again, you can, but if you use rounded versions, it makes your answer less and less accurate. So if I do 324 divided by 180, I get 1.8. That didn't, I'm not going to do that. 9/5. This reduces down to 9/5. So it's 9 pi over 5. Okay, you try this one. Hit pause. Come back when you're ready. Hopefully you got 4. I have to convert degrees, or the leftover degrees, to, no, it's all degrees. 28.66 degrees. I want degrees to go away. I want radians on top. There's pi radians in 180 degrees. Degrees cancel, so I have 28.66 pi over 180. And if I type that in, 28.66 pi divided by 180, I get 0.5002113636. Apparently they're going out 1, 2, 3, 4 places, so one didn't bump it up. Alright, how many degrees are in pi over 3 radians? In pi over 3 radians, now we're going backwards. Alright, well, I don't want radians, so put them on the bottom and make them go away. I want degrees, that's on top. The conversion rate is there are pi radians in 180 degrees. In just a second. Okay. Sorry, I had a coughing fit there. Alright, radians will cancel, pi's will cancel, and I'm left with 180 over 3, which is 60 degrees. Okay? Convert the radian measure to degree measure. If that's radians, and I don't want radians, I put radians on the bottom, degrees on top. There are pi radians in 180 degrees. Radians cancel, so I have 360 over pi degrees. They don't normally leave pi in answers of degrees. They do leave them in radian measures, but usually in degree measures they don't leave pi involved. So 360 divided by pi is approximately 114.59 degrees. Alright, you try this one, hit pause, come back when you're ready, and hopefully you got 1. Alright, so 7 pi over 8 radians. To convert, I don't want radians, that goes on bottom, I want degrees. Pi radians, 180 degrees. The pi's cancel, so I have 7 times 180 over 8 degrees. So 7 times 180 divided by 8, and you get approximately, well, exactly 157.5 degrees. Alright, try this one. Hit pause, come back when you're ready, and hopefully you got 3. Alright, this is radians. To get rid of radians, I'm going to put radians on bottom, degrees on top. Pi radians, 180 degrees. Radians cancel. So I have 3.2798 times 180 all over pi. So 3.2798 times 180 divided by pi. And you get approximately 187.9186976. 2 places, the 8 bumps it up to a 2. Alright, so how do you convert between degrees and radians? You use the conversion rate. There are pi radians equal to 180 degrees. So you use that conversion rate to convert between the two. Alright, here's where I thought we were talking about a little while ago. Arc length, okay? If you take a circle and you make a sector or a piece of the pie, this crust of the pie is what we call an arc, okay? And to figure out the length of that arc, they use the letter S for arc length. I don't know why they used an S for something that starts with an A, but they did. So arc length is equal to its radius, which would be from here to here, times theta, whatever that angle is that cuts the arc. Okay? If the angle is given to you in radians, you use this one. If the angle is given to you in degrees, then you use this one. Okay? And it's because you have to convert. Alright, so it says find R if S is 40 and theta is 20. Okay? Because my angle is in degrees, I know I have to use this one. So we're finding r if s is 40 and theta is 20. So I know s is 40 equals pi times the radius, which I don't know, times theta, which is 20, over 180. So the first thing I'm going to do is multiply by 180, kill the fraction. So I got 180 times 40, that gives me 7,200 equals 20 pi r, right? If I multiply these three together. To get r alone, then I'm going to divide by 20 pi, and the radius of this arc, or the radius of whatever's cutting this arc, is going to be 7,200 divided by 20 pi. And you get the radius, whoa. Hold on. Yeah, sorry. Use parentheses. I didn't use parentheses here, and I got like 1,130 because it divided by 20 and then multiplied by pi. Make sure you put that in parentheses on the bottom when you type it in. So my radius would be 114.59 centimeters. Right? The bottom one says find s, which is the arc length, if the radius is 2 and theta is 25 radians. Since my degree is in radians, I'm going to use this formula. So arc length, which is what I'm looking for, is my radius, which is 2, times theta, which is 25. So my arc length would be 50 inches. Okay? Alright, this one says find r if s is 1.5 feet and theta is pi over 4 radians. Since we're in radians, we use this formula. And it gives me s is 1.5. It gives me r, and no it doesn't, I'm looking for r. And it gives me theta is pi over 4. So what I'm going to do is divide by pi over 4 to get r alone. And r would equal keep, change, flip. I'd have 1.5 times 4 divided by pi, and the radius would be about 1.91 feet. Alright, this one says find theta in degrees and radians if arc length is 3 and radius is 1. To find it in degrees, I'm going to use this formula and plug in what I know. And it says 3 is pi times 1 times theta, which is what I'm looking for, over 180. So this would be 3 equals pi theta over 180. I'm going to kill the fraction, so I'm going to multiply by 180, which is 540, equals pi times theta, divide by pi, and I get 540 divided by pi. Theta would be approximately 171.89 degrees. Okay, and if I find it in radians, then I plug in 3 for s, 1 for theta, 1 for r, and theta. To solve for theta, I would get theta equals 3 radians. Yeah? Alright. We try this one, hit pause, come back when you're ready. And hopefully you get 12 inches. They're giving you in radians, so we need this. They're asking me to find s, which is 6 times 2, which is 12 inches. Try this one, hit pause, come back when you're ready. And they left it in terms of pi. Alright, so this one they gave me degrees, which means I have to use this formula. So I have 14 equals pi times radius times 42 all over 180. Oops. I'm going to multiply by 180. That's 2520 equals 42 pi r. Divide by 42 pi, divide by 42 pi. And again, they left my answer in terms of pi, so all I can do is try and simplify this. And if I type in 2520 divided by 42, you get 60. So this would come out to 60 on top over pi on bottom equals the radius in centimeters. There you go. All right. Part of your homework is they're going to talk to you about what the degrees are on a compass. These are all the directions that you see on a compass. And what they're trying to get you to see is that a compass is pretty much a unit circle. Okay? When you go to east and northeast, that's 30 degrees. Northeast is 45 degrees. North-northeast is 60 degrees. And then all the way up to north is 90 degrees. And that's all it's trying to get you to see. Okay? Alright, so what is a radian? Use that definition that we have on the, just use the definition from the book. How do you find the length of an arc? Well, you have two different formulas. You can either find arc length equals radius times theta if you're given radians, and if you're given degrees, and I gotta flip back. Goes for the pi r theta over 180. Pi r theta over 180. Pi r theta over 180. There you go. Alright. Oh, we're at homework, so we are done. Happy homeworking, and I will see you next